from YUMIN Primary School.
My name is GUO CHENGXI from YUMIN Primary School.
This lesson is Calculus, Chapter 5, Indefinite Integral. Remember, for the past two lessons, we have used the first method and the second method. Right now, we'll use the third method, which is by trigonometric substitution. Okay?
Yes.
So first, what should we let?
We will need to let x to be tangent or cotangent theta.
Why would you choose tangent or cotangent?
As sine and cosine only can be 1 to -1, but secant and cosecant cannot be 1 to -1. Only tangent and cotangent can be everything.
Yes. Okay, so for this, what is the range for theta? What is the range for theta?
The range is from negative half pi to positive half pi.
How about the x?
Dx will be secant square x d theta.
You mean like this, right?
Yes.
Okay, so we found these three, right?
Yep.
So right now for this, can we sub these in? Can?
Yes.
Like this, right?
Yeah.
Okay, so right now for this, secant square theta is 1 over cosine square theta. Well, this tangent to the power of 4 theta is sine to the power of 4 theta over cosine to the power of 4 theta. So can we numerator denominator times cosine to the power of 4 theta?
Yep.
So this is what will happen, right? Am I right?
Yep.
Can we first look at this denominator?
Yes.
So sine to the power of 4 theta plus cosine to the power of 4 theta. Because that the power is 4, your thing is a little bit too big, right? Do you remember the sine square theta plus cosine square theta, which is 1? Okay, so these two, when they expand, they will have the extra that we need to minus, which is the 2 sine square theta cosine square theta, right?
Yes.
Okay, so for this part,
I'm going to say another thing.
because that later on you have 2 theta, right? So here you also need 2 theta, which is the double angle formula for the cosine to theta, right? Right now, okay. Like this. So for this half, we can put it to the front first. So first, this part, this will have the 1. So first, here is a 1. So for this part, we'll have a sine 2 theta, right?
Correct.
Sine 2 theta times sine 2 theta over 2, right?
Right.
Here's a half. Sine 2 theta times sine 2 theta, what is it?
Sine 2 theta times sine 2 theta, which is sine. Is it an x? Is it theta, you mean?
Yes. Okay, so actually right now you can times the 2 in. Like this. Okay, so right now for this part, we can separate them. So for this, first this part, you know what would it be? Can we put the cosine 2 theta inside here? Can we?
Yes.
So right now for this part, which is actually this 2 minus sine squared 2 theta. 2. Can we use this part? Use this? Can? The sine squared theta plus cosine squared theta, which is 1.
Write it higher, your words are dropping.
So like this, is it right?
Yes.
Okay, so for this part, what can we have? Can we factorize?
Yep.
next is for this part, right?
Right.
Right now for this part, can we factorize something?
Yep.
So we can factorize the cosine square to theta, right?
Correct.
So after when it is like this, for this part, it's very obvious that here there's the ln, the logarithm. Okay, actually we can partial fraction first, okay? Because I hear this plus, so it doesn't matter about the order. So like this, then what can we have here? Can we put this into this part? Can?
Yes.
Is there extra half here?
Yeah.
Is there half?
Wait.
Wait, okay.
So fast.
So let me look at this. So first we have this half 1 over square root 2 and this 1 over square root 2, right? When it times up. Okay, so what you want to say is that there is the extra 2 square root 2, right?
Yep. And it's okay.
So it would be a 4 square root 2.
And plus, yeah, we use is.
Like this, right? Right? So do
We
you know
use
what?
the a squared minus b squared.
Okay, you mean that one is at this part, right? So for this one, we integrate. The constant doesn't matter. Am I right?
Yep.
So the positive will be ln square root 2 plus this sine 2 theta. And the negative will be ln square root 2 minus sine 2 theta. So this is a positive and this is the negative. Okay, and for this part we'll use this, right?
Yep.
So for this 2, which will be the negative 2, I mean square root 2, right? Will be the 1 over square root 2, like this, right?
Yes.
Right now we have this inverse tangent, right?
Yep.
Like this,
Yeah.
correct?
Yes.
This part, because that sine 2 theta, we can't just straight away put the theta inside, right?
Yep.
So we can change it into another form. Am I right?
Correct.
Which is how we'll use this, right?
Yes.
And right now at this part, what can we use? Tell me what can we use for this part? This one, right?
Yes.
Okay, so this is for the tangent to theta. Remember, you have a 2 here. So 2 and this square root 2, it can become just a square root 2, right? So you can have a square root 2 up here, am I right?
Correct. Correct.
Like this, right? So at this part, we can have a triangle. Okay, remember our assumption?
Yep.
According to our assumption, the x is tangent theta. It can actually be the x over 1, right? And tangent is almost over adjacent. So, which is x, which is a 1? First of all, which is the x, which is a 1? Like this, right? After that, the hypo, we can use the Pythagoras theorem to calculate. Okay, so yeah, it's like that, right? So this square root 2 will plus sine theta. It will be the x over square root x squared plus 1. Then the cosine theta will be 1 over square root x squared plus 1. So these times together, and it will be here's the x over x squared plus 1, right?
Yes.
Okay, and remember, because there here is square root 2, square root 2 and a 2. So can we simplify them?
Yep.
And this part here, can we just straight away sub in?
Yes.
Like this.
Yeah.
So right now, for this part, can we numerator denominator times x squared plus 1?
Yes.
Like this, is it right? for this, you see from this. Okay, using this trigonometric substitution, we also can get the correct answer, right?
Correct.
Okay, and for this, we use all these, right? There is a double angle formula, right? The formula, the sine squared theta plus cosine squared theta, which is 1, right? And it's a double angle formula for sine 2 theta, cosine 2 theta, and tangent 2 theta. Okay? Okay?
Yes.
And we also use the a squared minus b squared, right?
Yep.
And at this part, we also use the integral dx squared over x squared plus a squared, right?
Yeah.
Okay, and for these, we also have that triangle, which helps us with the sine theta and this cosine theta, right?
Yes.
So this is for the third method. In the next lesson, we'll continue with the fourth method. So can we end here right now? And do you have anything to say?
If you like our video, don't forget to subscribe to our channel.
Okay. Thank you for your watching.